You know, every single time you click your mouse, you're kicking off this incredible chain reaction, one that zips from your screen all the way down to a microscopic city of transistors and circuits. So today, that's the journey we're going to follow, from our clicks right down to the chips.
Think about it. You do this hundreds of times a day, right? You send an email, you post a photo, you jump on a video call, but have you ever just stopped for a second and wondered about the invisible journey your command takes the moment you click? Well, that's exactly what we're going to unpack right now.
Okay, so to really understand that journey, we first need to get our bearings. We need to look at the world where it all happens, our digital life, today. At the very heart of all this is a skill that you are literally using right now: digital literacy. And look, it's not just about knowing which button to press. It's so much more. It's about how you find information, how you figure out if you can trust it, and then how you use it to create something totally new or just talk to other people. Honestly, it's the new reading and writing.
And it really does connect everything. I mean, whether you're a student digging through digital books for a paper, or you're part of a team working together from different continents, digital literacy is that invisible thread tying it all together. It's the framework for pretty much how we work, learn, and connect with each other now.
So, if digital literacy is the skill, what are the tools we're using? Let's pop up a level and talk about the software. You know, the programs and apps we're actually clicking on every single day.
I bet you recognize some of these. You've got tools like Slack for instant messaging, Google Drive for sharing files without a second thought, and Trello for keeping projects on track. These things haven't just made teamwork a little bit easier, they've made it possible to collaborate in real time from literally anywhere on the planet.
But here's where it gets really interesting. The apps we see and use every day, they're just the tip of the iceberg. See, beneath the surface, there's this whole other kind of software working silently in the background, making everything else possible. And you've got to understand the difference. Okay, think of your computer like a house. The application software, that's your web browser, your video games, your word processor, that's all the furniture. It's the stuff you actually use. But none of it would even be there without the system software, things like Windows or Mac OS. That's the foundation of the house, the plumbing, the electrical wiring. It's the stuff that runs the house itself. All right, so we've talked about the furniture and the foundation. Now let's head down to the basement and take a look at the actual engine that powers the entire house, the hardware. So this diagram here, this is basically the roadmap for every single computer ever. It shows the whole journey of one command. It starts with an input, like your mouse click, goes to the central processing unit, which does all the thinking, and then comes out as an output, like a letter appearing on your screen. Right in the middle of that map, you've got the CPU, the central processing unit. This thing is the undisputed brain of the whole operation. And this brain really has two main jobs, and they're handled by two very different parts.
So inside that brain, you have two specialists. First up is the Arithmetic Logic Unit, or ALU. Just think of it as the master calculator. It handles every single bit of math and every logical decision, like, is this statement true or false? Then you've got the Control Unit. It's the traffic cop. It doesn't do the math itself, but it directs the flow of all the data, telling every other part what to do and exactly when to do it.
You know, to really appreciate the absolute miracle of that tiny CPU, that traffic cop and that calculator working together on a chip the size of your fingernail, we need a little perspective. So let's take a quick trip back in time. The entire history of modern computers can really be told as a story in 5 parts, or generations. And each one is defined by a single, massive breakthrough that made computers way smaller, way faster, and unbelievably more powerful than the one before it.
We start in the age of giants. Seriously, the first-generation computers were absolute monsters. They filled entire rooms with machinery that ran on thousands and thousands of these things called vacuum tubes. They got incredibly hot, they needed constant maintenance, and they would burn out pretty much daily. Then, the transistor came along. This was the hero of the second generation. It did the exact same job as one of those big, bulky vacuum tubes, but it was microscopic in comparison, used way less power, and was so much more reliable. This one little invention changed absolutely everything. So the next big question for engineers was, hey, why are we wiring these transistors together one by one when we could just print them all at once? And that's what the third generation gave us, the integrated circuit, which etched hundreds of transistors onto one tiny silicon chip. All of a sudden, computers got way more powerful and shrank all over again. And that brings us to our modern era, the fourth generation microprocessor.
Engineers figured out how to cram not just hundreds, but thousands, and then millions of transistors onto a single chip. They put the entire CPU, the whole brain of the computer, onto that one tiny little square. The power of a room-sized machine was now sitting on your desktop. The personal computer was born.
So we've seen how a machine that filled a room became a tiny chip that puts incredible power right at our fingertips. But with great power comes a new set of rules. Let's bring it all back home and talk about what it means to be a responsible user in this world we've built. Think about it this way. Knowing how a car's engine works is one thing. Knowing how to drive safely in a world full of other drivers is something else entirely. It's the same thing online. Understanding the technology is only half the battle. Using it ethically, well, that's the other half.
So, what are the new rules of the road? Well, because that powerful network connects all of us, we need to practice digital etiquette. Because it's so easy to create and share, we have to respect copyright. Because all that data is so valuable, we have to practice good cybersecurity. And because every single click leaves a trace, we have to be mindful of our digital footprint.
We've gone on quite a journey, haven't we? From a simple click, down through the software, into the very brain of the machine, and all the way back through generations of innovation. You now know what's under the hood, so the real question isn't just about how you drive anymore.